friends. Welcome. I am Dr. Nitin Naik from the Department of Structural Engineering, Sanjoni College of Engineering, Kopargaon. Friends, so far we have discussed about interior of Earth, then sources of earthquake, the theory of plate tectonics, and the rebound theory, which are responsible for earthquake. Now, in this lecture, we will discuss about different types of faults and types of the waves which are generated during the earthquake. So let us start with faults. What is mean by fault? Fracture between two rock two rock masses is termed as fault. When there is a fracture, when there is a crack, then it is termed as fault. And its extent is the surface along which movement occur. Most of the faults are at the ocean depths. Normally faults occurs at the ocean depth or at great depth in the ocean. Movement at a fault can be either in a horizontal or in a vertical direction or both. Horizontal means the rock mass may slide in this direction or maybe in the vertical direction. The horizontal line interface relative to the north between the fault plane and the horizontal plane is called as strike. So this is the term related to fault. So what is mean by strike? Strike is the horizontal line interface relative to the north direction between the fault plane and the horizontal plane. So here this is the horizontal plane, here this is the horizontal plane, please follow the cursor, and here this is the fault plane, this is the fault plane, and this is strike of the fault, this is the strike of the fault, this S indicates strike of the fault, or this is the line, strike line. Okay, and this is fault plane along which the movement is taking place, and this is the horizontal plane, this is the horizontal plane. So here S indicates strike slip component, D is dip slip component, H is it is the extension, it is the extension. Okay, now here the horizontal line interface, so this is the interface relative to the north direction between the fault plane and the horizontal plane is called as strike. So when you are defining a strike, you have to define it with respect to the north, and the angle between these planes is called as dip. The angle between these two planes, horizontal plane and the fault plane, is called as dip. So here this is the dip, here this is the dip, because this is angle between the horizontal plane, this is the horizontal plane, and the fault plane. So this angle is called as dip of the fault plane, dip of the fault plane. Now let us move further. Types of faults. So there are two types of faults: strike slip fault and dip slip fault. So what is meant by strike slip fault? This type of fault, it occurs when movement is parallel to the strike. Movement is parallel to the strike. Usually the fault plane is nearly vertical and the plate surface on one side of the fault slides horizontally past the other. So here this is the figure which shows strike slip fault. So this type of fault occurs when movement is parallel to the strike. Now here this is the strike, here this is the strike, and the movement of rock masses is parallel to the strike. So this block is moving to this direction, the second is moving to this direction, and this is the strike. So movement is parallel to the strike. Usually the fault plane is vertical. So here this is the fault plane, here this is the fault plane along which the fault occurs. So this is the fault plane, and normally the fault plane is nearly vertical, and the plate surface on one side of the fault, so this is the plate surface on one side of the fault, this is fault, one side of the fault moves to the right, or left. So it slides horizontally past the other. If the block opposite an observer looking across a fault moves to the right, then it is termed as right lateral. It is termed as right lateral. So here this figure indicates the right lateral fault. Why? Because the block opposite to the observer. Now the observer is standing somewhere here, and this is the block opposite to the observer, and this block is moving to the right, and therefore it is called as right lateral. Similarly, this is left lateral because the block which is opposite to the observer, remember the observer is standing here, and the block which is opposite to the observer is moving to the left, and hence it is called as left lateral. So these are the two types of strike slip fault. Remember, in strike slip fault, the movement of the blocks is parallel to the strike, means slip is taking place along the strike. Okay, and depending upon the movement of the block opposite to the observer, further the strike slip fault, it can be classified as right lateral or the left lateral. Okay, then second one is dip slip fault. Dip slip fault. So these are the two figures showing dip slip fault. Dip slip fault, in this type of fault occurs when rock on either side of a fault slip relative to each other along an inclined plane. So again, now this is the this is the strike, this is the strike line or strike, and here this hatched portion is plane of the fault, is plane of the fault, and these are the two rock masses. This is the first one and this is the second one. Okay, now here the slip slip on either side of the fault is relative to each other and taking place along this inclined plane, along this inclined plane, hence it is called as dip slip fault, hence it is called as dip slip fault. Again I will move to the first figure. So this is dip, this is dip angle, angle between the horizontal plane and the fault plane is called as dip, and dip slip fault means the movement is taking place along this dip, along this dip, this is dip angle and along the inclined plane. Okay, inclined plane. If the rock mass above an inclined fault moves down, it is termed as normal fault, otherwise it is called as reverse fault. So this is normal fault because the mass of the rock above the inclined plane is moving in downward direction, and it is obvious thing, the block is moving down the plane is obvious in mechanics, it is because of the gravity, and that's why it is called as normal fault. But if it is moving up the plane, inclined plane, then it is called as reverse fault. And thus these are the two types of dip slip fault. First one is normal fault and second one is the reverse fault. Now after studying these faults, let us move to the seismic waves. So what are the seismic waves? There may be a question in the mind, what are the seismic waves? Now seismic waves are the waves of energy. We know during earthquake, why earthquake takes place? It is only because of the strain energy stored in the earth mass or in the rock mass, and release of strain energy is called as earthquake. So seismic waves are the waves of energy which is released during the earthquake, waves of energy caused by the sudden breaking of rock within the earth or an explosion. They are the energy that travels to the earth and is recorded on seismograph. So seismograph is an instrument which is used to record the seismic waves. So this figure it shows a seismograph. This figure shows a seismograph. It consists of spring and the suspended weight and a rotating drum. And when the movement of Earth's surface takes place, this weight it oscillates and it records the waves on the rotating drum. So it is a plot. This is a plot. This is a plot, and the instrument which plots the the seismic wave is called as seismograph, and the plot is called as seismogram. The plot is called as seismogram, and the instrument which records this plot is called as seismograph. Okay, so let us move to the waves now. Types of seismic waves. There are several different kinds of seismic waves, and they all move in different ways. So each wave is moving differently, behaving differently. The two main types of waves are body waves and surface waves. Body waves and surface waves. Body waves can travel through the Earth's inner layer, while the surface waves can only move along the surface of the planet, like ripples on water. Earthquake radiates seismic energy as both body and surface waves. So the seismic energy is released through the earthquake in the form of body waves or surface waves. So what is meant by body waves? Body waves, these are the waves traveling through the interior of the earth. So traveling through the interior of the earth, body waves arrives before the surface waves emitted by an earthquake. So body waves arrive before the surface waves, remember, emitted by an earthquake. These waves are of higher frequency than the surface waves. So frequency is higher. There are two types of body waves, P waves and S waves. So what is meant by P waves? P waves are primary waves or compressional waves, also called as compressional waves. The first kind of body wave is the P wave or primary wave. This is the fastest kind of seismic wave, and consequently the first this is the first wave to arrive at a seismic station. Seismic station is a station where the waves are recorded. So this is the first wave which arrives at a seismic station. This is body wave. The P wave can move through solid rock and fluid like water or the liquid layers of the earth. So this wave can move through solid mass as well as through liquid. It pushes and pulls the rock through which it is moving. P waves are also known as compressional waves because of the pushing and pulling they do. Subjected to a P wave, particle moves in the same direction that the wave is moving in, which is the direction that the energy is traveling in. So wave is traveling in one particular direction, it means the energy is traveling in that direction, and is sometimes called as direction of wave propagation. The direction in which the wave is moving is called as direction of wave propagation. So here this animation, it shows P wave or compressional wave or P wave or the compressional wave. Okay, so this is P wave. See, this is at t is equal to 0, at time t is equal to 1. See, the particles are compressed. Further, at t is equal to 2, the portion is moved in the direction of propagation of the wave. And again, this is the position of the compression of particle. So particle motion is in the direction of wave. If you observe this animation, you please observe this black square, how it behaves. So the now wave is propagating, and now the this square, it is subjected to compression. Watch again, it is subjected to compression, and that's why the wave is called as compressional wave. This is the fastest kind of seismic wave, and this is the first wave which arrives at the seismic station. It is called as compressional wave because of the pushing and pulling of the rock masses through which it is traveling. See how the wave is traveling, how this square is behaving subjected to compression. See, just watch it again. It is subjected to compression and again pulling, and the particle motion is in this direction. Particle motion is in this direction, and this is the direction of movement of the wave. So this is all about P wave. Now S wave, we will discuss about the animation later on. This is the second type of body wave, which is called as S wave or secondary wave, which is the second wave you feel in an earthquake. So this is the second wave, and previous was the primary wave. And S wave is slower than the P wave and can only move through solid rock, not through any liquid medium. So this wave cannot move through liquid medium. It can move through solid rocks. S wave move the rock particles up and down or side to side, perpendicular to the direction of the wave or direction of wave propagation. Now this is the behavior of the wave at t is equal to 0 before the earthquake, t is equal to 1, this is t is equal to 2, t is equal to 3. Now the direction of particle motion is perpendicular to the direction of propagation of the wave. This wave can pass through solid rocks having sufficient shear strength. It cannot pass through liquid medium because liquid is having no shear strength, and that's why it cannot pass through the liquid medium. It is also called as shear wave. Let us observe the animation now. Observe this black colored square, how it is moving. So it is moving up and down, it is moving up and down, or the movement may be side to side like this. Just observe the cursor, side to side. So this is the direction which is perpendicular to the direction of wave, and we know the shear stress, it takes place because of shear failure which is along the plane. So particles are moving like this in vertical direction along this plane. So this is shear wave. It cannot pass through liquid medium because liquid cannot offer shear resistance. Now after discussing the body waves, let us discuss about surface waves. Surface waves traveling only through the crust, through the surface of the earth. Surface waves are of lower frequency than body waves and are easily distinguished on a seismogram as a result. So these waves can be observed or distinguished on a seismogram easily because these waves are having lower frequency. Though they arrive after body waves, it is surface waves that are almost entirely responsible for the damage and destruction associated with earthquake. So these waves are having lower frequency. These waves are having lower frequency than the body waves, and that's why are entirely responsible for the damage and destruction associated with the earthquake. Now, when the wave is having lower frequency, then amplitude is maximum, will be maximum like this. And if the wave is having higher frequency, then it results in reduction in the amplitude. And when amplitude is less will be the damage. When amplitude is high, more will be the damage, and that's why the surface waves are entirely responsible for the damage during the earthquake. Okay, there are two types of surface waves. First one is love waves and Rayleigh's wave. So love wave, this is the first kind of surface wave. It is called as love wave, named after A.H. Lowe, a British mathematician. who worked on the mathematical model for this kind of wave in 1911. It is the fastest surface wave and moves the ground from side to side, confined to the surface of the crust. This wave is confined to the surface of the crust because this is basically a surface wave. Love waves produce entirely horizontal motion. Entirely horizontal motion. Here we will see the animation for love wave. Okay, this is the fastest surface wave and moves the ground from side to side, and it is confined to the surface of the crest only. So here this is the figure for love wave at t is equal to 0, t is equal to 1, t is equal to 2, 3, etc. And this is the direction of particle motion. See, the particle motion is horizontal. You can observe this square block, how it is moving. Yes. So it is moving like this. Here also see, this is the direction. You can observe on this surface how the particles are moving. See, particles are moving in this direction. So it produces entirely a horizontal motion. So this is love wave. Now relic wave. The other kind of surface wave is the relic wave. It is named for John William Strutt and Lord Rayleigh, who mathematically predicted the existence of this kind of wave in 1885. A Rayleigh wave rolls along the ground just like a wave rolls across a lake or ocean. So it is very much similar to a wave which we can observe on the surface of the ocean. Because it rolls, it moves the ground up and down and at the same time side to side in the same direction that the wave is moving. That the wave is moving. Most of the shaking felt from an earthquake is due to Rayleigh wave, which can be much larger than other waves. So shaking is mainly taking place because of the Rayleigh wave. Okay. Now we will observe the behavior of element under the Rayleigh wave. This is the element under consideration. You please observe the animation and see how the particle is moving, and again here you can observe the movement of the particle on this surface. See, it is very interesting animation. It shows the movement of this surface. You observe it on this surface. So the particles are moving in the direction of the wave as well as in the horizontal direction. Okay. So this is the behavior of a Rayleigh wave. Thank you. So this is all about the type of faults and types of waves. In the next lecture, we will discuss a few more things which are related to earthquake. Thank you.